The purpose of this demo is to show you how to build a prediction model. So here I'm going to take a specific use case from a telco point of view, specifically customer churn prediction. For this, I'm going to use a couple of tools, IBM SPSS Modeler for the data mining purposes and ClickView for the business intelligence and reporting purposes. The primary purpose of this demo is to show how we can effectively build a prediction model, what kind of manipulation needs to be done on the data to improve the accuracy of a model as compared to directly applying one of the classifiers and so on. So we will see that in detail pretty soon. The business value delivered primarily by this specific use case is to help telecom companies predict who are the customers that are potentially going to churn. So through this, they will be able to actively devise a strategy as to how they can retain these customers, thereby providing multiple benefits. To name a few, it is always easier to retain your existing customers. It's always more cost effective to retain your current customers as compared to acquiring new customers. It can also help to devise better marketing strategies because it sort of gives you a detailed picture as to why these customers are leaving, so that you can target them and devise strategies that is going to keep them with you. So these are some sample screenshots that we have. We'll go directly into the demo. So this is the IBM SPSS modeler. I've actually built the model just to save some time in this demo, but I'll walk through each and every item in detail as much as possible. So these are the input records that we have. So CRM demographics data, billing information, transactional data, and customer products. And we are merging it using customer ID field, as you can see here. The final output looks something similar to this one. So here is a view of the combined records. So you have the customer ID field, which is common across all the information. So from the demographics data, you get to see the zip code, the state, district, city, the age category, basically the date of birth, gender, what kind of an account, language preference, income earned in thousands, number of children, level of education, their marital status, etc. From the billing data, you get to see what kind of usage do they have in terms of say how much of the services are they using, what is the average bill payment in a month, how long are they taking to pay the bill after the due date. Such information will be provided. And then from the transactional data, we capture information about how often are they calling the customer care center, what kind of questions are they asking, what categories do they fall under, how many complaints were filed, how many complaints were resolved, etc. And this is a product's information, so we get to know, we have given some instance names for the product. So each code corresponds to a particular product type and when was it installed, from how long are the customers to these people, to the telco operator specifically. And this is their current status. So either they're active or deactive. So deactive records are of the customers who have churned already, and active records are of the customers who are currently active with the telco operator. So the purpose of us having a good mix of records is to ensure that our training model gets both sides of the coin, so it will be able to generate business rules as to why a customer is continuing, and it will also be able to understand why a customer is leaving. As an overview, what we are essentially doing here is we are making use of all this information. We are going to build a prediction model, and we are going to apply that prediction model on a new data set, as you can see here, and we will be able to predict whether this customer is going to leave or is going to stay based on the model that we are generating. So we'll see step by step how we are doing it. So as you can see, the first step is to merge all the information together. put them in one file and send that as an input to this one. This is basically a type node. I am using this type node to do some analysis on the existing data. Sort of gives me an overview of how the current data is. So let me quickly open this audit node and execute this. All right, so I have defined a particular variable as a target variable. So I'll show you what it is, the service status. So this one gives you the description about how much percentage of records are actually active and how much record is actually deactive. It's an important statistics to look at, because as you can see, there's almost 66% of the record comes from the active part and only 35% coming from the deactive part. So if I use this data as it is and try building a prediction model, my model could be skewed. So it could be biased towards the rules that are coming out of active customers. So the key in data science is to ensure that you have a balanced sample data. So for that, what I'm essentially doing is I'm using a technique called as undersampling. So this is a clustering node. There are multiple options for you. I specifically use k-means clustering here because it allows me to define how many clusters I want to generate. So when I say clusters, I mean you could assume it as buckets. So the model, the algorithm built in this one uh, puts customers into different models, different buckets based on some specific logic on its own. So it is preferred doing this way because it's better than doing it manually. The manual part may not be a true representation of the complete population, the sample size that you're going to pick. So we will leave it to the prediction. We will leave it to the model that is going to be running here. So let me execute this one. So this is the model that gets generated as a result of this one. So we'll go and do a little bit of analysis on this. So I'll go to the clusters view. And this will also help you in understanding um, what fields are going to be important for you when you're trying to build a prediction model. This is not going to be a final model, but it will sort of give you an idea, fair idea. So as you can see, VIP account type, marital status, these are the fields that are actually going to be the most important fields, and further down the line, the least important fields. So it doesn't really matter at this point of time. I'm using this primarily to create a good balanced sample. So I'll go and first analyze the numbers. So as you can see, clusters 3, 2, and 1, it's ordered in a descending order. So, and this is the field I want to go and verify. So as you can see in cluster 1, the service status of all the records are actually 100 are active, and everybody is single. So if I use this particular data, I am not going to achieve a good rules definition because it's going to be skewed. And if you take a look at the other clusters, you could see there's a good mix of active and deactive customers. So cluster 3 has close to 58% of deactive customers, and cluster 2 has close to 64% of active customers. So putting them together is going to approximately give me a decent balanced sample. So I'll also verify the numbers. So as you can see, it's 177 and 150, and the balance is also going to be ensured because the sample size is also almost equal here. If I add cluster 1, I'm actually going to add 131 records with only active status and marital status as single. So the rules may not be that valuable. It might become a little obvious from a business point of view. All right, so having said that, let me close it, and I'm going to discard all the records coming from cluster 1. So that's pretty much what I'm doing here by adding a select node. All right, so the next step is partitioning the data. So here I'm trying to achieve one particular goal. I'm going to divide the sample size into two categories, the training set and the testing set. The training set is going to be used for building a prediction model, and I'm going to test that particular model on the testing set before I apply it on the new data set, as you saw earlier, so that I can be assured that I'm getting a decent level of accuracy and confidence before I apply it on general data, because this general data is what marketing people or general business people are going to use to devise their strategy. So it needs to be pretty accurate. All right, so in the partitioning, in this particular use case, I'm just dividing it into 50-50%. As you can see, 50% will be training and 50% will be testing. This is the percentage here. So in the training set, I am going to further do a little bit of more analysis. My goal is to create a model that is really accurate. So I don't want to overcomplicate the entire process. So I'm going to eliminate few input fields that may not be important in predicting the outcome. So the less number of input fields that you have, the rules are going to be richer and more useful from a business point of view. So it's not mandatory, but it's something sort of a good practice, the best practice that we follow. So I'm using a couple of modeling nodes here, algorithms here. So one is the association rules, and the other one is feature selection node. So association rules, this is the model that gets generated. It is very commonly used in market basket analysis, but I am using here to understand what are the most important fields. So I do not want to keep the confidence level pretty high. So I'm just keeping a confidence percentage of 75% here. Usually I would go for a 90-95% if I'm doing market basket analysis. But my goal here is to just eliminate some input fields. So I'm keeping the confidence level low to see what level of inputs are required to generate the rules. So this is the model that was generated as a result of association rules. We'll go inside and analyze if we are able to eliminate any of the input records. So scroll down, excluded inputs. Unfortunately, we do not have a conclusive result here. So it says all input, models were built based on the inputs that are provided, all the input records we have provided. So I'm not able to eliminate any input records here, but further I said we could use feature selection node. In feature selection node, it sort of tells you what are the important fields and unimportant fields. So this is the model that was generated. So in doing further analysis, as you can see, it sort of gives you what are the important fields, the ones which are marked by a tick mark. The other ones are marginal, and the rest of things are going to be unimportant for you. And these three fields are completely irrelevant for our analysis. So those three fields were screened by default by this model. So since the sample size here is not really a telco grade one, we have just used a sample data to build a model. So I would go ahead and eliminate only these three fields and keep the other unimportant fields as well, so that the model gets a little bit more accuracy. So a type node would be added ideally, and the fields that are not important are going to be marked as none. So, and the other fields will be given as input. The target variable will be defined for as service status, and there are a couple of other fields that were generated as a part of previous steps. So this is a result of the partition node. This is a result of the k-means clustering node. So both of them were changed to none. All right, so we have almost reached the stage where we are ready to build a model using classifiers. So I'm using multiple options here to see which one gives me a better accuracy. So I'm going ahead with decision tree as the any outcome. I'm also using neural networks. So these are multiple classifiers we have. And these are the multiple options within decision trees. Here you have quest, you have cart, you have C5, and you have chain. And this is the neural network. And these are the individual models that are generated as a result of these decision trees and neural network. This one is an analysis node. If I run this, it will tell me what is the current accuracy of this particular model. As you can see, it gives me a 90% accurate prediction. Similarly, I would do an analysis of rest of the models that are generated. It gives me 83%. So basically what I've done is I've actually analyzed everything, and as you can see, there are a couple of models that were pretty close. One was close to 90, the other one was 91%. So I am going to use those two models. I'm going to test that model on the testing set to see which one's giving me a better accuracy. So these models were primarily generated on the training set, and it was applied back on the training set, and that's giving me a 90% accuracy. So when you apply this model on a testing set, the accuracy is likely to be less than what you achieved earlier. So that's not a surprise, but a more accurate model here need not necessarily mean a more accurate model when we apply it on the testing set. So that's primarily why we are actually testing it here. So the two close ones were trade and C5. So let's verify which one has better accuracy. So C5 gives me a 67.66% accuracy, whereas the child model is giving me 73.65%. This is a decent level of accuracy that we have achieved as a result of this. And as a comparison, if this is the original data that we have, so let me show you a typical comparison. So we have finalized child as the model, right? So we will use directly apply child here and just verify if the target variable has been defined here, and none of the variables are changed to anything because we have not done any analysis on the data. So rest of the fields are given as input, and server status has been defined as the output. And if I run this particular model, it will generate another prediction model. If you remember, we obtained around 74% of accuracy using that. So here, if you verify, let me add an analysis node. It's giving me only a 67-68% accuracy. So as you can see, it's 5% more accurate. So every 5 in 100 records that you're going to predict is going to be better for you. This is a common question that we get from different telco operators. They say that they have a very matured model, their model works really well. How can we come and improve what they're doing? This is a very simple example of how we can go in and make use of the current information, the data that they have, and build a better model, build with more accuracy. That's that's going to result in better business for the telcos. So here, like I mentioned earlier, we'll go to the next part. Scroll down here. So this is the new set of records. So we're going to merge it. We're going to change the type, define variables similar to what we had earlier. So record ID, the other fields which were not important will be changed to none. There is no target variable, as you can see, because this model is going to create the target variable for us. So all these customers, the records coming from these tables, are currently active customers, and by application of this particular model, we are going to predict whether the customers are going to be active or are they going to churn. So after application of this model, I have generated a table output. This can also be exported in multiple formats. As you can see, this is the table, and this is a new field that gets added. So the customers who are marked as deactive are the ones who are going to leave, and customers who are marked as active are the ones who are going to be continuing with the same telco operator. All right, so this is exported into an Excel sheet. Here I'm just concerned about customers who are going to be deactive so that I can do some analysis, understand where the churn's happening, how the churn's happening, etc. So I am going to extract the data in Excel sheet of customers who are only going to churn, and that's given as input to ClickView. So this is the ClickView screen. ClickView is our business analysis partner. So here I'm going to go into this particular use case for customer churn analysis. All right, so these are the reports that we have generated here. I'll go to the dashboard view. So the output that's coming out of IBM SPSS modeler is primarily an Excel sheet. So this is also a common problem we have come across in multiple telcos. So they have the information, but they do not have a good reporting structure that is going to help them in looking at their data in a really flexible way. So we have given this data as input to this. This sort of gives you a heat map across the region. So since we have used data from Switzerland in random, you're actually seeing a map of Switzerland over here with an account of people from different regions, different states. I guess they're called as cantons. All right, so this one gives you the potential total revenue currently, and this is the potential revenue that will be seized if the customers leave. This is the count of number of customers who are active and going to be churned. This is the potential revenue per account type. Similarly, we can go into a detailed report, and if you want to see a drill down option of say how many customers who have called customer care with question on LTE service are going to leave, this would give you a detailed view of that one. If you want to do a gender wise analysis as to see okay how many male customers are going to leave who have questions on LTE, it can also be anything else. It can also be like for internet. You would be able to see this flexible level of reporting. So that's about it for this demo. Thank you.